Hello everyone, I'm Siriji from Sri Venkateshwara College of Engineering, 6th SEM, Department of Computer Science and Engineering. I'm here to discuss the topic cloud computing and its application. And the topics are Introduction, Defining a Cloud, Cloud Deployment Models, Cloud Computing Reference Model, Computing Platform and Technologies, Virtualization, Pros and Cons of Virtualization. Coming to introduction, cloud computing is a technological advancement. It is based on the concept of dynamic provisioning, which is applied not only to services but also to compute capability, storage networking, and information technology infrastructure in general. Resources are made available through the internet and offered on a pay-per-use basis from cloud computing vendors. Cloud computing is the most recent emerging paradigm promising to turn the vision of computing utilities into reality. Defining a cloud. Different notions of cloud computing is shown in the figure. The internet plays a fundamental role in cloud computing since it represents either the medium or the platform through which many cloud computing services are delivered and made accessible. Cloud computing refers to both applications delivered as services over the internet and the hardware and software system in the data centers that provide those services. This definition describes cloud computing as a phenomenon touching on the entire stack, from the underlying hardware to the high-level software services and applications. It introduces the concept of everything as a service, mostly referred to as XaaS, where the different components of a system, IT infrastructure, development platform, database, and so on, can be delivered, measured, and consequently priced as a service. The approach fostered by cloud computing is global. Cloud deployment models. Public cloud. Public cloud are the most common deployment models in which necessary IT infrastructure is established by a third-party service provider that makes it available to any consumer on a subscription basis. Such clouds are appealing to users because they allow users to quickly leverage compute, storage, and application service. In this environment, users' data and applications are deployed on cloud data centers on the vendor's premises. Large organizations that own massive computing infrastructure can still benefit from cloud computing by replacing the cloud IT service delivery model in-house. This idea has given birth to the concept of private clouds as opposed to public clouds. In 2010, for example, the US federal government, one of the world's largest consumers of IT spending, started a cloud computing initiative aimed at providing government agencies with a more efficient use of their computing facilities. The use of cloud-based in-house solution is also driven by the need to keep confidential information within an organization premises. Institutions such as government and banks that have high security, privacy, and regulatory concern prefer to build and use their own private or enterprise cloud. Whenever private cloud resources are unable to meet users' quality of service requirement, hybrid computing system partially composed of public cloud resource and private owned infrastructures are created to serve the organization needs. These are often referred to as hybrid clouds, which are becoming a common way for many stakeholders to start exploring the possibilities offered by cloud computing. Cloud Computing Reference Model. A fundamental structure of cloud computing is the capability to deliver on demand a variety of IT services that are quite diverse from each other. This variety creates different perceptions of what cloud computing is among users. Despite that lack of uniformity, it is possible to classify cloud computing service offering into three major categories. That is infrastructure as a service, platform as a service, and software as a service. Each layer provides a different service to users. Information as a service solutions are sought by users who want to leverage cloud computing from building dynamically scalable computing system requiring a specific software stack. Information infrastructure as a service are therefore used to develop scalable websites for background processing. Platform as a service solution provides scalable programming platform for developing application and are more appropriate when new systems have to be developed. Software as a service solution target mostly end users who want to benefit from the elastic scalability of the cloud without doing any software development, installation, configuration, and maintenance. Computing platform and technology. Amazon Web Service. AWS offers comprehensive cloud IaaS service ranging from virtual compute, storage, and networking to complete computing stack. AWS is mostly known for its compute and storage on-demand service, namely Elastic Compute Cloud, is also known as EC2, and Simple Storage Service, that is S3. EC2 provides users with customizable virtual hardware that can be used as the base infrastructure for deploying computing system on the cloud. It is possible to choose from a large variety of virtual hardware configuration, including GPU and cluster instances. S3 is organized into buckets. These are containers of objects that are stored in binary form. Users can store objects of any size, from simple files to entire disk images, and have them accessible from everywhere. Microsoft Azure. Microsoft Azure is a cloud computing system and a platform for deploying applications in the cloud. It provides a scalable runtime environment for web application and distributed application in general. Application in Azure are organized around the concept of the roles. Currently, there are three types of role: web role, worker role, and virtual machine role. The web role is designed to host a web application. The worker role is a more generic container of application and can be used to perform workload processing, and the virtual machine role provides a virtual environment in which computing stack can be fully customized, including the operating system. Virtualization. Virtualization plays an important role in cloud computing since it allows for the appropriate degree of customization, security, isolation, manageability that are fundamental for delivering IT service on demand. Virtualization technology are primarily used to offer configurable computing environment and storage. Particularly important in the role of virtual computing environment and execution virtualization technique. Among these, hardware and programming language virtualization are the techniques adopted in the cloud computing system. Hardware virtualization is an enabling factor for solution in the infrastructure as a service market segment, while programming language virtualization is a technology leveraged in platform as a service offerings. In both cases, the capability of offering a customizable and sandboxed environment constituted an attractive business opportunity for companies featuring a large computing infrastructure that was able to sustain and process huge workloads. Moreover, virtualization also allows isolation and a finer control, thus simplifying the leasing of service and their accountability on the vendor side. Virtualization allows us to create isolated and controllable environments. It is possible to serve this environment with the same resource without them interfering with each other. If the underlying resources are capable enough, there will be no evidence of such sharing. It allows the reducing number of active resources by aggregating virtual machine over a smaller number of resources that become fully utilized. Pros and cons of virtualization. Advantages of virtualization. Managed execution and isolation are perhaps the most important advantages of virtualization. In the case of techniques supporting the creation of virtualized execution environment, these two characteristics allow building secure and controllable computing environment. A virtual execution environment can be configured as a sandbox, thus preventing any harmful operation to cross the borders of the virtual host. Moreover, allocation of resource and their partitioning among different guests is simplified, being the virtual host controlled by a program. This enables fine-tuning of resource, which is very important in a server consolidation scenario and is also a requirement for effective quality of service. Portability and self-containment also contribute to reducing the cost of maintenance, since the number of hosts is expected to be lower than number of virtual machine instances. By means of virtualization, it is possible to achieve a more efficient use of resource. Multiple systems can securely coexist and share the resource of the underlying host without interfering with each other. Disadvantages. Performance degradation. Performance is definitely one of the major concerns in using virtualization technology. Since virtualization interposes an abstraction layer between the guest and the host, the guest can experience the increased latencies. For instance, in case of hardware virtualization, where the intermediate emulates a bare machine on top of which an entire system can be installed, the cause of performance degradation can be traced back to overhead introduced by the following activities: maintaining the status of virtual processors, support of privileged instruction, that is trap and simulate privileged instruction, support of paging within VM. Thank you.